So let's talk about how we solve absolute value inequalities. If the absolute value of x is less than a, then that means x is between negative a and a. Let's consider if the absolute value of x is less than 6. So when is that true? What x's satisfy this? What numbers have absolute value less than 6? Well, here's 0 and here's 6. Well, for instance, 5, the absolute value of 5 is less than 6. The absolute value of 4 is less than 6. 0 is less than 6. So all of these numbers, the absolute value is less than 6. And it's also true that the other side, negative 1, negative 2, negative 3, negative 4, negative 5, all of these numbers, the absolute value is less than 6. But when you get to negative 6, now the absolute value would be equal to 6. So we want to exclude that. So it's going to be from here to here. So that's why we would write x is between negative 6, positive 6. That's if the absolute value is less than a number. If the absolute value is bigger than a number, then either the number is less than negative a or bigger than a. Let's look at the absolute value of x is bigger than 4. When is that true? Well, here's 4, here's 0, here's negative 4. And any number that's bigger than 4, the absolute value will be bigger than 4, not including 4, because the absolute value of 4 is 4. But also anything out here will work. The absolute value of negative 5 is bigger than 4, because it's 5. And anything over here will work up to, but not including 4. So we have that x is either less than negative 4, or x has to be bigger than positive 4. So this gives our approach to how we would solve an absolute value inequality. We want to get the absolute value by itself, and we can use one of these two methods depending on the direction of the inequality. Let's look at some examples, and we're going to give our answers in interval notation. So here I have the absolute value of 5 minus 2x is less than 7. So this is a less than. The absolute value is less than. Which of these two situations is this? It's this one here. So we want whatever's inside to be between negative 7 and 7. So I can get rid of these absolute value signs by placing it in between negative 7 and 7. And now I can solve this compound inequality by solving for x. I'm going to subtract 5 from all sides. On the left I have negative 12. In the middle I have minus 2x. And on the right I have positive 2. So now I want to get rid of this negative 2 by dividing by negative 2. I'm going to do it to all three sides. But when I multiply or divide by a negative number, I have to switch the inequalities. So here I have positive 6 is bigger than x is bigger than negative 1. So if I want to write this in interval notation, I can draw a tiny picture to see what's happening. Here's negative 1. Here's 6. I want x to be in between there, not including the ends. So that tells me negative 1 to 6, not including the negative 1, not including the 6. This is the solution set. Anything in there will make this thing true. The absolute value, if you take 5 minus 2 times any number in there, will be less than 7. Well, what if I have the absolute value of 4x minus 5 is greater than or equal to 7? Now we're in the one on the right over here. If it's absolute value bigger than something, either I'm less than a negative or bigger than the positive. So this means either 4x minus 5 is less than or equal to negative 7, or 4x minus 5 is bigger than or equal to positive 7. So we solve these two things separately. Adding 5 to both sides, I get 4x is less than or equal to negative 2. I divide both sides by 4. Getting rid of that 4, I get x is less than or equal to negative 1/2. Or over here I add 5 to both sides. I get 4x is bigger than or equal to 12. I divide both sides by 4. This cancels with this. I get x is bigger than or equal to 3. So x is less than or equal to negative 2, or bigger than or equal to 3. In interval notation, what does that look like? Again, I'll draw the picture. Here's negative 1/2. Here's 3. I want everything less than or equal to negative 1/2, and then I want everything bigger than or equal to 3. I'll start from the left here at negative infinity. Negative infinity up to negative 1/2 is the first red block. I don't include the negative infinity, but I do include the negative 1/2. You never include the infinities. On the right, I have a 3 that goes up forever. I include the 3, don't include the infinity. Now it's an or, so anything on the left will work, or anything on the right. So I use the union to combine these two sets into one set.